Welcome to the electronics class for November the 5th. I have looked at the homework assignments that you guys turned in as of a few minutes ago. If you turned one in right before class started, then I won't have seen yours. But I was very impressed with what I saw. Most of you got it really well. A few of you are close. A few of you didn't turn anything in. So finger wag for those of you that didn't turn one in. But let's talk about some of the ones that people did turn in. Let me share some of them with you. Okay, so this one here, I think this one was Luke's, right? Luke, do you claim this one?
Yeah, I claim this one. This
Okay.
is mine.
All right. So Luke likes to be a little different, and I encourage people to be different, so that's good. So he decided that instead of using the push button switch right here, the one that most normal people would have used, okay, Luke decided that instead of that, he would use this other switch, which is the slide switch here, which is one that I hadn't planned on talking about just yet, but we're going to have to talk about it eventually. So now is as good a time as any. Okay, so the way it works is you see the one here is common, and then the one over here is terminal 1, and the one over here is terminal 2. So when the switch is in this position here, the common and terminal 1 are connected. Terminal 2 is not. So if you want to connect up the terminal 2 and ground, you have to put the switch over on the other side. So when we start the simulation here, you can see what happens is that, so the light comes on. So this must be the output light. When I click on the switch, you see it goes to the other side here. And so now this one comes on. Now, although I commend Luke for what he's done, actually, because he used this switch here, we didn't really need a transistor, okay? We could have very easily taken this switch, and so let's say right here, okay, so we could have just taken the switch here, and we could have connected this up so that, it goes, or actually, well, let's see. I don't want to take the time to actually do it, but basically we could have hooked up one LED to that side of the switch and the other LED over to this side of the switch. And if we connected them up right, then we could do what we want to do without even using a transistor. Okay, so now he actually did use a transistor, so cool for him. But I just want you to be aware that the way he did it here, didn't really need a transistor. And I wanted you to do it in a way that it could only be done with a transistor. Okay, so let's set his aside now. Let's look at this one here. This one, I believe, was Eric's, I think. Correct me if I'm wrong there, Eric. So when
This looks like mine.
It is? Okay, good. All right, so when I start the simulation here, you see the light comes on. Okay, good. And when I push the button, the light goes off. Okay, but I don't have a light here confirming that that the button has been pushed. So if just looking at it, I don't know whether the button has been pushed or not. So I would have preferred that you had a light over here somewhere, so that when I push the button, then this light over here by me comes on, and that one goes off. Okay, not a huge complaint, but I would like you to go back and redo that. So please redo that. And then this one here, this is the granddaddy. Okay, this one is Cadence. So Caden went the extra mile. Okay, so what he did was he set up a bunch of gates all on the same board. And by the way, this is what I'm going to ask you guys to be doing tonight. So Caden's ahead of the game here. So let's start off with the NOT gate. So he's got a little thing here telling me NOT gate. So I presume he's talking about this button here. So let's see if it works. So when I push this button, okay, you see the light goes off. Okay, so that must be the NOT gate. Okay, so the next one is what he calls a NAND gate. So let's play with that and let's see what that is. Okay, so the way he's got it labeled here, I'm presuming that this is the NAND gate. Okay, now, what is NAND? So last time we talked about an AND gate, but what he's doing, he's not doing an AND gate, he's doing a NAND gate. So a NAND gate is an AND gate followed by a NOT gate. All right, so let's figure out what the logic tree would look like for that. Okay, so what I'm going to do is I'm going to make up a table here. And I probably need a little more room here. So let me zoom out just a bit here so I can have some room. Okay, so, and by the way, what I'm about to do is something that you guys need to know. So pay close attention. So I'm going to look at I'm going to have what I call an A input, and I'm going to have a B input, and then I'm going to have an output. It would help if I could spell output correctly. Okay, now this output that I'm going to put here is what the output would be if it was an AND gate. Okay, and then I'm going to follow that with the NOT output. And you'll see what I mean by that in a minute. Okay, so let's just think about a regular old AND gate. So the only way the output for an AND gate would be high is if both A and B are high. So if that's the case, then the output of the AND gate is going to be high. But remember, he's not doing an AND gate. He's doing what's called a NAND gate. And so what he's doing is he's taking the output from the AND gate and he's putting that through a NOT gate. So the NOT is whatever the input, or so the output is whatever the input is not. So this is the input to the NOT gate, so the output is going to be low. Okay, so if we have anything else, so if we have low and high, then our output to the AND gate is going to be low, but the AND gate is going to be high. If we have high and low, well, that's not going to work because they have to both be high, so the output's going to be low, which means the final output is going to be high. And what if these guys are both low? Well, the output there is going to be low, and so the output of the NOT gate is going to be high. Okay, so we want to test to see if Caden has done this correctly. So we're going to use this table here to see if it's good. All right, so now let's zoom in a little closer here. Okay, and remember that if I'm understanding things correctly, and by the way, please tell me if I'm not. Okay, so this is our NAND gate. Okay, so what I want to do is, so these are both low right now. So that means the output of our AND gate should be high, which, yep, it is. Okay, so the only way that I can make the output be low is if both of the inputs are high. Okay, so if I were to come in here, if I were to click on one of these buttons, it should not do anything. So I'm clicking and nothing's happening. So if I click on this one, nothing should happen. And in fact, nothing does happen. Okay, so the only way I can make the output be low is if both of them are high. And so remember, the way to do that in Tinkercad is to hold down the Shift key while I click it. So I'm going to hold down the Shift key and I'm going to click the one on the right. Nothing happens. Now I'm going to click the one on the left. And hey, what do you know? It goes off. So bingo. He has, in fact, correctly done a NAND gate. So congratulations. All right, now let's see if he did the NOR gate correctly. And so first off, we have to say NOR gate. What the heck is a NOR gate? Well, it's going to be the same thing. It's an OR gate followed by a NOT gate. So let's do the same thing that we did before. So here's our A, here's our B, here's the output of the OR gate, and then here's the final NOR output. Okay, so if A is low, B is low, the OR gate is going to be low, and then when we NOT that, then it's going to become high. So if this is low and this is high, then this guy is going to go high, which means the not is going to make it low. If this is high and this is low, well, remember, this is an OR gate. So the OR gate is going to be high. And then when we're not that, it's going to be low. Okay, and then our other possibility is they're both high. If that's the case, the OR gate will be high, so the NOR gate will be low. All right, so let's test it and see. Okay, so right now, none of the buttons are being pushed. So that means that the output should be high, and sure enough, it is. Okay, that's good. Okay, so now, according to our logic table here, if I push any button at all, doesn't matter which button, it should go low. All right, let's see if that is in fact what happens. Okay, so I'm going to push this one and it goes low. I'm going to push this one and it goes low. So yay, he has correctly done what he claimed to do, which is way above and beyond what I asked you to do. So congratulations on that, Caden. Very nice. I'm very impressed. There is one thing that I kind of would have preferred is the same thing as I told Eric. And this is just a personal preference for me. I like it so that when you push a button, like let's say we push this button, I like to have a light down here that comes on. It just kind of gives me a nice warm feeling. So same with all of these. I would hope that for every button, there would be a light. So when I push the button, the light comes on just to confirm to me that everything's working right. Now, it's obviously not something that you have to do, but it kind of gives me a warm, fuzzy feeling. Yeah, so Caden is saying he could do that for the next assignment. Yeah. Okay. So congratulations to all of you who did it. Almost all of you did it exactly the way that I wanted you to do it. And those of you that didn't do it quite the way I wanted, you were really close. Okay. So I did put the initial deadline for this assignment as being today at 2:15, or yeah, 2:15 is what it was. Okay. Now, because some of you were really close, I have decided that I'm going to go in and I'm going to extend that deadline. So as soon as class is over today, I'm going to go into Canvas and I'm going to change it to make it be due next time we meet, which for this class is going to be Monday. Okay. So I'll allow you to redo it without penalty as long as you can do it by Monday. But of course, I have a new assignment for you to do today. And I'm sure you can guess what that new assignment is. But just in case you can't guess, okay, let's go up here and let's go down. Let's go to our modules. Okay. Some of you may have already looked in Canvas and seen this. Okay. So why is this behaving weirdly here? Oh, it's still, there we go. Okay. All right. So this is the assignment that I'm going to give you today, which is going to be due next Tuesday. So today we're going to do the AND and the OR gates. Now, I don't want you to do the NAND and the NOR, although if you want to do those in addition, then hey, you will have my admiration if you do them in addition. But all I want you to do to get full credit is just a plain old garden variety AND gate. And the schematic for the AND gate is shown here. And in addition, I also want you to do the OR gate, and the schematic for the OR gate is here. Now, I would like you to do them on the same Tinkercad file. So you guys saw the way that Caden had all of his gates there on the same breadboard. I would like you to do the same thing. Please create both of your breadboards or both of your circuits on the same breadboard. That way you can just send me one link rather than sending me two. It makes life easier for me. And if you guys make life easier for me, then that's good for you. Keep me in a good mood here. You don't want me grumpy. Okay. And so that's it. That is all that I had planned to do today, was just to give you this assignment. And I'm hoping that just by looking at the schematic and by building on what you did previously with the NOR gate, hopefully all you need is the schematic. You should be able to figure out what to do. Okay, so tell you what I'm going to do now. I'm going to say, if you don't have any questions, If you can take this description that I've given you now and you can run with it, then you can go ahead and type buy into the chat box and go ahead and get busy working. If, on the other hand, you're not exactly sure how to go about this, then stick around and let's talk about any questions you have. Okay. All right. So if you're going to go start working, then goodbye. If you have any questions, then now is a good time to ask your questions. Not hearing any questions, not seeing any questions.
Thank you for class.
Hey, my pleasure. So nobody has any questions? Wow. Okay, we'll see how you guys do then.
Oh, hold on. Can you hear me now?
Yeah, I can hear you.
Okay, so does it say how much? So is it just 220 ohm, like a 220 ohm resistor for both inputs on the end?
Ah, okay. Thank you for asking that. I wish you'd spoken up and said that sooner, because I bet you there's a lot of other people that probably have the same questions there. Okay, so for the values on these transistors, or I'm sorry, the values on the resistors, okay, it depends on how bright you want your light to be. So let me zoom in a bit here and let me turn on annotation here. Okay, so if the resistor is the one that's connected to your light, like for instance, look at this guy right here. You
Yeah.
can see that what's happening here is that the electricity is coming, it's coming here, it's going through that resistor and then through the LED, and then from here it's going somewhere which I presume is going to ground. He's just got it going through this through a multimeter first. Okay, so this is the resistor that basically controls how bright you want your LED to be. Okay, so 220 is a good value for those. I mean, it depends on the voltage. It depends on how much voltage you're using, really. So you'll notice that he chose to use a 9-volt battery. Okay. If you remember what I did when I made my circuit, I did not use a 9-volt battery. I used a 4.5-volt, a 3-pack of AA batteries. Okay, so if you're going to use a different battery here, well, yeah, that's going to change your voltage, or that's going to change the value of this resistor. 220 might be a good value for this resistor if you're using 4.5 ohm or 4.5 volts. But if you're going to use 9 volts, you probably better pick a different value for that resistor. Okay, so the short answer to your question is it's up to you.
Okay, so it just really depends on how much voltage you use within your circuit. Okay.
Yeah. In fact, you see, when Caden made his circuit here, he put multimeters into his circuits because he wanted to have these light bulbs be as bright as he could without damaging them. And he remembered that the max current through an LED is 20 milliamps. Now, if you go a little bit above 20 milliamps, you're not going to immediately damage the LED, but it will shorten its lifetime. Okay, so he made up his mind that he wanted to have 19.5 milliamps. So I'm willing to bet that what he probably did was he probably just did trial and error. He probably just he tried 220 ohms, and then he looked to see what the current was. And if the current was less than 19.5, then he said, okay, then I'll go with 210. Or maybe I'll go to 200. He probably just did trial and error until he got the right value so that he has 19.5 milliamps flowing through it. So that's what I would recommend for you to do too.
Okay, thanks.
Okay. So anybody else got questions? I see there's a few others of you online here.
No, not really. I just kind of stayed on just to see in case like there was something else I could learn.
Yeah, well, I think Isaiah's question there was a really important question, and I wish everybody could have heard the answer to it because it was an important concept. Okay. How about Luke? You got any questions?
No, I was actually same reason as Brian.
Same reason with Brian, okay. All right. Well, if that's the case, then I think I'm gonna go ahead and just end the class.
Okay.
And so good luck with making your circuits, guys.
Yeah. See ya.
Yeah.
Okay, bye.